What's up guys, my name is Ritvik Rustagi and today I'm here to teach you everything you need to know for AP Calculus AB and BC Unit 1, Limits and Continuity. So before I begin, if you haven't already, please go to the description right now and get my free AP Calculus AB and BC books because those books have everything you need to know to get a 5 and an A in your class. So what are you waiting for? Get it right now, and now let's begin immediately with Unit 1. So Unit 1 begins with limits and our limit notation. So limit is denoted as a limit as x approaches c, so that x and the right arrow sign to c, that goes up a little below the limit, right? It's like a subscript of f of x equals to r. So that means that as x approaches c, a certain value c, then f of x approaches r. So I'm going to give you an example of this graphically. So basically this is a function f of x. And then I want to find the limit as x approaches 1 of f of x. So clearly it's simply f of 1, which is 1 in this case. So in this situation, it was pretty simple to find the limit because we could just use direct substitution. However, it's not always that simple. So basically, that's when left and right hand limits come in. So it's important to be able to estimate limit values for graphs and tables. So basically a one-sided limit is the y value that a function approaches as we approach an x value from either the left or the right side. So the left-hand limit is limit as x approaches c with a minus sign of f of x, and then the right-hand limit is the limit as x approaches c with the positive sign of f of x. Because the right-hand side means it's coming from the positive x, while left-hand side means it's coming from negative x. And then a limit at a point exists if and only if the left and the right-hand limits, they both approach the same value. So let's look at an example. So this is the graph of the absolute value of x over x. What is the limit as x approaches 0? So we can see that as x approaches 0, right, from the left hand side, then the limit is minus 1. But as x approaches 0 from the right hand side, the limit is positive 1. And since both of these don't equate to each other, the limit does not exist. So we can write DNE, which means does not exist. Now observe this table and find the limit as x approaches 1 for f of x. So as we can see, as x, right, goes from 0.9 to 0.99 to 0.999, f of x is going from 1.9 to 1.99 to 1.999. This is clearly approaching 2 from the left-hand side. Now let's look at the right-hand side. So when x goes from 1.1 to 1.01 to 1.001, f of x goes from 2.1 to 2.01 to 2.001. Clearly, this is also approaching 2. So the answer to this is 2. Now, let's look at some limit rules. So the limit of a constant is just that constant, right? Because, for example, the limit as x approaches a of c is just going to be c because x, that variable, has no effect on the constant. Now, if we want to find the limit, right, of two functions summed up to each other, then we can separately find the limit of each function. And this works for subtraction also. If we're given the difference of two functions, we can separately find the limit of each function. Now, if you want to find the limit of the product of two functions, then we can separately find the limits of each individual function and then multiply both of them. Now, if we want to find the limit of f of x over g of x, then we can separately find the limit of the numerator, which is f of x, and then separately find the limit of the denominator, which is g of x. Now, if we want to find the limit of a constant times a function, we can factor the constant out and then simply find the limit of that function. Now let's learn the squeeze theorem. Now I'm not going to spend much time on this, and the reason is that I basically went through every free response question for both AP Calculus AB and BC from like 1970, and there's like maximum one problem that involves the squeeze theorem. So it's not important. The squeeze theorem is often referred to as the pinching theorem, and if we're given that f of x lies between g of x and h of x, and if the limit as x approaches c of g of x is a, and the limit of x as x approaches c of h of x is also a, then that means the limit as x approaches c of f of x is also going to be a, because f of x is between g of x and h of x. Now, there's three types of discontinuities: a jump, infinite, and removable. So to find infinite and removable discontinuity for a rational function, factor both the numerator and the denominator. Then the term that cancels out will make the removable discontinuity. And then after you cancel out that common term, you set the denominator of the simplified expression to 0 to find the points of infinite discontinuity. So let's look at an example. We're given this rational function x squared minus 2x minus 8 over x squared plus 7x plus 10, and we want to find the points of discontinuity. Well, let's factor the numerator and denominator, and when we do that, we get x plus 2 times x minus 4 divided by x plus 2 times x plus 5. Clearly x plus 2 will cancel out, and since that term cancels out, a removable discontinuity will occur at that point. So there's a removable discontinuity at x equals to negative 2. So after canceling that out, we're left with x minus 4 over x plus 5. And now we set the denominator of this simplified expression, right? So x plus 5 to 0 to find that the infinite discontinuity occurs at x equals to minus 5. Now, defining continuity at a point. Well, for a function f of x, right, it will be continuous at a point c if f of x is defined at c and the limit as x approaches c of f of x equals to f of c. And then note that for a limit to exist, the left and right hand limits must also equate to each other. So let's look at an example. So f of x equals to x squared when x is less than 1, and it's 2x when x is greater than or equal to 1. So now I want you to tell me if this function is continuous at x equals to 1. So to figure that out, we first find the limit. So the right hand limit and the left hand limit. So the left hand limit will involve the function x squared because it's defined for x is less than 1, which is to the right of 1. So if we plug in 1, we get 1 squared, which is 1. So that's the left hand limit. Now for the right hand limit, we will use 2x since it's defined for the points greater than or equal to 1. So on the right side of 1. And if we plug in 1 into 2x, we get 2. Now we can also find that f of 1 equals to 2. Now clearly the function is not continuous at x equals to 1. And the reason is that the limit does not exist because the left hand limit and the right hand limit, they both approach different values. Now confirming continuity over an interval. Well, I highly recommend memorizing when each of these functions are continuous. Now for example, the natural log function will be continuous when x is greater than 0. Now f of x equals to 1 over x, that's going to be continuous for all points except when x is 0. And f of x equals to x squared is continuous for all points. F of x equals to sine of x, again continuous for all points, and the same story for cosine of x. And then the tangent of x will be continuous for all points of x except when x is pi over 2 plus n times pi. Now, let's connect limits at infinity to horizontal asymptotes. So rational function is in the form f of x over g of x. Now if the degree of f of x is less than the degree of g of x, then the limit as x approaches infinity of this rational function is 0. Now if the degree of f of x is more than the degree of g of x, then the limit as x approaches infinity of that rational function will simply be infinity. So that means there is no horizontal asymptote. However, for the situation when the degree of f of x was less than the degree of g of x, the horizontal asymptote occurred at 0. Now if the degree of f of x is the same as the degree of g of x, then the limit as x approaches infinity of f of x over g of x is the highest degree coefficient for f of x. So basically the term with the highest degree, you take the coefficient of that, and now you do the same thing for g of x, and then you find the quotient of both. And then that's where the horizontal asymptote will occur, for the situation when the degrees are the same. Now let's look at a free response question from the actual AP exam. So please pause the video and try the problem. So basically by now I hope you actually tried the problem. So now let's begin with the solution. So we're given a function f, right? Which is x cubed minus x over x cubed minus 4x. And we want to find the limit as x approaches 0 of f of x. Now if we try direct substitution where we directly substitute in x equals to 0, we get 0 over 0. That's not good. So let's factor this expression to see if we can get something promising. So when we factor this expression, we get x times x squared minus 1 divided by x times x squared minus 4. We can cancel the x out and we're left with x squared minus 1 over x squared minus 4. And now if we directly plug in 0, there's no problem. We get 1 over 4 for the answer. Now part B says, find the point at which a removable discontinuity occurs. So the removable discontinuity occurs for the term that gets cancelled out from the rational function. So in this situation, we cancelled out the x. So that means a removable discontinuity occurs at x equals to 0. And now we can plug in 0 into our expression for f of x to get that f of 0 equals to 1 over 4. So that's the y value when x equals to 0. So the point is 0, 1 over 4. Now part C says, write an equation for the vertical and horizontal asymptote to the graph of f. Well, the vertical asymptote occurs when the denominator is 0 for the simplified expression for the rational function. So the simplified expression is x squared minus 1 over x squared minus 4. We set that equal to 0 to find that the vertical asymptotes occur at x equals to minus 2 and positive 2. Now to find the horizontal asymptotes, we take the limit as x approaches infinity of this function. And clearly the degree of the numerator and denominator is the same, because the degree of the numerator is 2 and the degree of the denominator is also 2. So we take the coefficient of the highest degree term. It's 1 for both because it's x squared and x squared for both the top and bottom. So that means the horizontal asymptote occurs at y equals to 1. Now let's look at another free response question from the actual AP exam. So we're given this function 2x minus 2 over x squared plus x minus 2. And for the first part, we want to find when this is discontinuous. Well, to do that, let's factor this first. So factoring this gives us 2 times x minus 1 over x minus 1 times x plus 2. So x minus 1 cancels out and we get f of x equals to 2 over x plus 2. So there's a removable discontinuity at x equals to 1 since x minus 1 cancels out. And our simplified expression is 2 over x plus 2. So now we set the denominator for that to 0 to find that there's an infinite discontinuity at x equals to minus 2. Now part B says, at each point of the discontinuity found in part A, determine whether f of x has a limit, and if so, give the value of that limit. So we want to find the limit of f of x as x approaches 1 and negative 2. So to find the limit as x approaches 1, we can simply substitute in 1 into 2 over x plus 2, which is a simplified version of f of x, and we simply get 2 over 3. Now, for the limit as x approaches minus 2, that's where the problem occurs. If we substitute in minus 2 now, we get 2 divided by 0. That's not possible. So now let's find the right-hand limit. So that means minus 2 is approached from the right-hand side. So x will be greater than minus 2. So something like minus 1, 0, 1, 2, 3, and so on. And that means 2 over x plus 2 will be a positive number. However, when we find the left-hand limit, that means x is approaching minus 2 from the left-hand side. So that means 2 over x plus 2 will be a negative number. Now clearly the left-hand and the right-hand limits will not equate to each other because they don't have the same signs. And that means the limit just does not exist. Now thank you so much for watching this video. And please don't forget to like, share, and subscribe, since that's going to tell me that you guys are truly enjoying and learning from the books and the videos that I've been making for you guys. And don't forget to join the Discord server to meet other hardworking students that are preparing for various competitions and exams such as the AP exams. And also, don't forget to follow the Instagram if you have Instagram to view educational reels and cool animations. And again, thank you so much for watching this video, and I really hope to see you soon back again on this channel.